All right, well, let's get started. My name is John Hess. I'm with CENIC and Pacific Wave, and today I'm joined by my colleague, Hervey Allen of the Network Startup Resource Center based out of the University of Oregon. And this afternoon, we want to talk to you about a series of workshops that the Pacific Research Platform has sponsored over this past year. And just for the sake, who all is not yet familiar with the Pacific Research Platform? Everyone knows about Pacific Research. Okay, all right, so the Pacific Research Platform is led by researchers here out of UC San Diego, and as well as UC Berkeley in the Northern California. And there are two groups. Citrus is an organization out of the northern UC campuses of UC Berkeley, UC Davis, UC Santa Cruz, and UC Merced. And Cal IT2 here in Southern California includes UC Irvine and UC San Diego. And so the PI of the PRP is Larry Smar, and there are co-PIs that include Tom DeFonte, Camille Crittenden, Frank Worthwine, and Phil Papadopoulos, who's now at UC Irvine. So the FIONA is an acronym that expands for Flash I/O Network Appliance. And this was developed by Phil Papadopoulos and Tom DeFonte on an earlier NSF-funded grant to develop high-performance servers out of commodity hardware. So what are the goals of the PRP FIONA workshops? So in the larger context of the R&E community, one of the things that we want to achieve is that the realization that our researchers should not also have to be cyber infrastructure engineers or network engineers. That hands-on training for our cyber infrastructure engineers and our network engineers can help them be more effective. That we would like to be able to assist them to develop and deploy end-to-end data movement, measurement, and analysis tools, and a better understanding of scientific workflows and where they may be able to make an impact. And then also democratizing access to data movement, container, and other cyber infrastructure technologies. And at last year's, in our National Research Platform workshop, the ESNet director, Inder Manga, had this great quote, throughput is more important than bandwidth. And so what we're trying to help our researchers and our cyber infrastructure teams realize is that it's not just the speeds and feeds of your connections, it's how effective those the throughput, the effective throughput that you can achieve. So how does this fit within the scope of the PRP and scaling the PRP to larger constructs such as the things like we want to roll this out to a national footprint, so a national research platform. How do we roll this out to a global research platform? Because our researchers are not, they themselves collaborate with their colleagues across the region, across the nation, and internationally. And a former ESNet director, Greg Bell, had this quote when we started the project that became the Pacific Research Platform. For the hardest problems, not just in physics and climate science and genomics, there are massive teams working around the world. Our job is to make geography irrelevant. So we had a series of workshops that Hervey is going to help us describe. And so I'm going to turn it over to Hervey.
All right. Good afternoon, everybody. So you're looking at our happy group in Bozeman, Montana last August, and the last workshop we ran before this one here recently. And it was a good group. We had a good time. So let's talk a little bit about what we've done with these PRP FIONA workshops over the last calendar year, last year essentially, since last March. We've run 4 workshops. We had a test workshop before we did all of this. We tested out our whole curriculum on the CENIC engineers in La Mirada also, which was extremely useful. So we ran this workshop series in CENIC last year in Monterey. We actually went to Copenhagen and worked with Nordunet and their engineers and ran this workshop there. That was pretty interesting. And they sort of put together their own kit of virtual machines to run all this software on. Then we did this again in Bozeman, and we've done it recently here in La Jolla, and we've done this at the Cal I-2 complex on the UCSD campus. And so over the last year, as you can see, these are all the various institutions that have taken part with their participants in the workshops. And that's pretty exciting to me because, as John brought up, the concept of not only a PRP, but an NRP and possibly a global research platform is well represented here because we have people from all over the United States who've attended the workshops. We tried to get some of the smaller universities and colleges involved as well, some of the tribal community universities. So it's been a really good crossover and mix of engineers from all sorts of strata and range of abilities and different types of infrastructure that's available to them. So for this workshop that we just completed this weekend, this is what the numbers look like. So we had 14 institutions among our 18 registered participants. And we had a number of people from some of the scientific labs that are based at the various universities, and UCSD was represented by 4 separate attendees across multiple labs. We also had some government agencies involved as well, and R&E networks like Kimber were at our workshop. You can see the list here of all the institutions. On top of that, we were audited by a few engineers, people who just came in for the first day or came in for the second day and were very interested in what was going on and wanted to hear this information. So we had a gentleman from the JGN Testbed Network, which is a project of NICT in Japan. And we also had 3 engineers from Preginet in the Philippines. They have a very large delegation here at CENIC this year. And one of their engineers came last year and joined us as a fellow of CENIC. So white doesn't work as well on the screen here, but I can read it to you. This is what we did over the last couple of days. We've adjusted our schedule a bit over the year as to what exactly we teach during the workshop. But essentially, we try to do some leveling and get people on board with just the basics, the tool, which is we're running all of this on Linux. And then what we do is we install PerfSonar test point bundle on top of Linux. We talk a lot about the science DMZ model and how these particular pieces of hardware might fit into that and larger pieces of hardware going forward and why we're actually doing what we're doing in the workshop. So we put PerfSonar on the boxes, and then we start building some meshes among all the boxes to simulate groups that might actually exist in the real world. And we start doing latency and throughput tests between the groups. And then on our Mad Dash meshes, we show people what the throughput is looking like, what the latency is looking like over time. Try to make this look like what it would look like if you actually did this on a larger network. And the students get to discover the excitement and fun of YAML and trying to pull together all of these various files and actually making these meshes work and getting minimal feedback when things fail and figuring out how to resolve it, which is really good because when you go back home and somebody hands you a box and says, put this in a mesh, if you haven't practiced it before, it might be difficult. Let's take a look. We also went through security around all of this. So a big social issue around the concept of a science DMZ oftentimes is that institutions are afraid to place any of their equipment outside of their firewalls. And so we talk about that, what that looks like, how you can do that, how you can secure, for instance, your data transfer nodes and your PerfSonar boxes that are sitting in your science DMZ, why firewalls actually restrict large data flows, what's going on there. Even if you bought that 10 gig capable firewall, why you're not getting 10 gigs through it, right? Because they really aren't designed to do that. And that usually brings up the most lively discussion in the groups. You get some pushback, you get some people who explain how they've done it at their institutions, and we got some great questions out of our students this year, asking exactly how they might be able to social engineer moving forward with some of these items. And at that point, these are what the actual FIONAs look like. And I'm handing this over to you at this point. Yes. And John will talk a bit about the FIONAs themselves.
So these are the examples of the hardware that we used in the workshop itself. These are gigabyte products from their Internet of Things line. This is the same hardware that we used in the across the workshops both in this past year. So in this case, in the most recent workshop, the participants took the FIONETs that they used during the workshop, they take them home and are able to use them in supporting activities at their home institution. So here's some of the, if you will, kind of like the diploma at the end of the workshop where the participants receive their FIONET. And so among our goals in these workshops, of course, is that everyone can enjoy it and come away with smiles, as well as a FIONET. Prize winners, yes. So among the information that we wanted to share was just kind of an idea of the details of the hardware that was setting up the workshop. So these FIONETs, these from the gigabyte line, are now kind of in the unattainium category. They are hard to acquire. They actually have a follow-on model that if you want to buy in units of 1,000, they're willing to talk. So we're currently seeking for the next generation of FIONETs that both in terms of availability, but also in the feature set, and I'll talk about that more in our lessons learned. But for kind of the bottom line figure here is around $18,000, allows you to deploy a classroom lab of about 35 FIONETs. One of the things that we found useful, particularly in Bozeman, where the participants were in Bozeman, but the FIONETs were actually remote here at Cal IT2, is Hervey very kindly set up some remote monitoring out of University of Oregon using Nagios to monitor the status of the FIONETs in San Diego. We found that during the class that the FIONETs got too hot and started dropping out. And we'll show a picture. This is the road case that we used in that installation, and we found that once the clock rate of the CPUs was pegged at their maximum, that perhaps we needed some more cooling in there. So here are some other images of the workshops. This one over here is from, this one's from our Bozeman, no, forgive me, that's from Monterey. Yeah. One of the nice excursions that we took on the second day of the workshop was to visit the Cal IT2 Sun Cave. This is where if you have the right 3D glasses, that you have a very immersive VR experience. And this is one of the applications of this is cultural heritage preservation. So I believe this is from Tom Levy's research. And then over on the right, there's another space there at Cal IT2, the room, that in this case, among the instructors that we had joining us, Joel Pelosi was describing here the instrumentation that they've done on the PRP Nautilus, which is a Kubernetes managed cluster. In this case, it's instrumented with Prometheus, and what we're seeing here on the back are Grafana visualization of the various resources across the cluster. So a few more images of the workshop this past weekend. And again, some happy faces from prior workshops with our co-chair, Tom DeFonte, and students from, in this case, from the Netherlands on the right. And then also from recent workshops and earlier. So I'm going to turn it over to Hervey to describe some of the software tools.
So to put all this together, there's a whole potpourri of software that we used. And one of the things that most of us really work with on a daily basis is GitLab. And so we put all our materials in the GitLab, and all of them are published and they're publicly available. And a large goal of all of this effort is to disseminate this knowledge as widely as possible and to make it available. So for instance, the specs for these FIONETs and that type of stuff are available. We have printed right here the workshop website. You can get to the prior workshops as well, but the materials, of course, have been updated and iterated over time. So the latest one's probably the best one. All the lab exercises, which we built on Jupyter notebooks. Half of the labs did Jupyter notebooks, and the other half were just standard copy, paste, or type in the commands yourself off of a web document. We also use Rocket Chat, so yet one more chat client that you can install and use, but we have a web interface for it, so that was good. And we signed all the students up for it right at the start of the workshop, and that way we can drop in things like API keys for connecting their measurement boxes to the Mad Dash mesh. And if there's any errors or anything like that, we can drop in fixes, comments, all that kind of good stuff. We use the Perf Sonar Test Point Bundle, which is a subset of the full Perf Sonar toolkit. And we install that, and that provides us with all the tools that we need to actually run the monitoring tests that we want to use. And those of you familiar with Perf Sonar, that includes pScheduler, which lets us set up scheduled testing across all of our various nodes. We do latency and throughput tests. The Perf Sonar Test Point Bundle does not come with a backend storage. Those sit on our mesh boxes that are receiving all the information, all the test results. And then the other piece of it is it doesn't come with the big Perf Sonar GUI that you get with a toolkit. It's all command line driven. So this was interesting for some of the students who are used to Perf Sonar because they may not have actually gone down to the command line and issued any of these commands or looked at some of the back end files that build Perf Sonar. We worked with a Globus Connect server for our throughput testing, and we showed the students how to do this. We had an Esmond client, which talks to the back-end database of data storage that Perf Sonar uses on our mesh boxes. So you can see a lot of bits and pieces of software. And then we threw in Nagios for good measure just to monitor our entire setup so that when things dropped, we knew it. And as John has mentioned, occasionally the FIONAs would drop, and this is largely, we believe, heat related. We had a couple of other little issues, and so having something monitoring was very useful. Talk about a few lessons learned after putting all this stuff together and actually trying to teach it to a group of students. One is it's a lot of bits and pieces, right? So actually, we learned we need to start earlier than expected and really run through the entire workshop methodically to try and avoid being caught by surprise. Even doing that, we still had some surprises, but that's also how people learn. And luckily, our students seem to agree with us because we heard that comment coming from them as well. We try to get input from a participant database and anybody else who might be interested in this effort. What should we be teaching? What would be useful? What is lacking? What do you need to know? And we went out and asked a lot of different people those exact questions to help build this curriculum. And then we just iterate, right? So at this point, we're in the 4th iteration, and these 2 days that we've come up with seem to be the core information that people really want, right? How do I build this thing? How do I get the mesh going? How do I use one of these FIONets in order to do some measurement? And then the other piece of that is, okay, well, let's talk about the higher level science DMZ concept, data flows, and security, and kind of have a roundtable discussion and talk about how we socialize some of this. The hardware, as John mentioned, evaluating the cost-benefit ratio. So the FIONets that we were running ran about $360, and they included 4 gigs of RAM and 256 gigs of flash, basically flash drive memory. And since they're no longer available, we're looking for the next candidate. And one of the big pieces we'd like to have in the next candidate is some sort of built-in lights out manager or OOB serial console access. That would be extremely useful, especially for a workshop like this, but just in general, anytime you deploy something like this, having a way to get to the device out of band can be extremely useful if it goes away for some reason. And another possibility is looking at having more storage on these devices, because you could put quite a bit on these devices these days, particularly if you started doing NVMe. You can squeeze an amazing amount of storage in a very small space with NVMe, and it's very fast. And then you were going to talk about the next set of lessons learned, I believe. Yeah. Okay. Thanks.
So part of the lessons, again, as Hervey was describing earlier, is the budgeting time to really scrub the materials that we use. There were, in the Jupyter notebooks, there were portions in this case that there were some self-induced opportunities, if you will, that there were bugs in the scripts or references to files on a master node that were old references. So things like iterating over those materials to make sure that the focus of the workshop is actually learning the content and not actually faults of debugging. Yeah, debugging. One of the, Jupyter Lab and Jupyter Lab notebooks are a fantastic tool for teaching, but they can lead to kind of a behavior of clicky right through the lab without really thinking through what's actually happening. And so one of the things that we think about is how can we design those notebooks so that we give pause to perhaps contemplate what's actually happening under the hood, so that we get more understanding through those notebooks. For communications, is also, as Hervey's mentioned, we want to be able to seek to kind of on the continuous improvement model. We want to seek input from the community as to how we are structuring the workshops, the content that we're delivering, the pace of the workshops. Are we hitting the right subjects? Do we need to, say, for instance, do we need to do more about science engagement, as well as the base details of how you deploy or consider a deployment? And again, as part of the cooperative agreement with the NSF, as part of sharing the resources and helping others distribute the materials and distribute the knowledge. And so this is, again, trying to model both the cost profile and materials for putting on their own workshops. So I think we have reached our point. Do you have questions for us?
Let's get the microphone over. Yeah. There we go.
Mechanic's assistant, being an overseas participant, it would be great if you can have a remote participation of those workshops. Just because, you have your own machines somewhere over the network. So the rest is about the, online courses or stuff like that, just transmitting audio and video. It will be extremely useful for us who are not living in California.
Good suggestion.
Yeah, that's a great suggestion. One of the thoughts that we've considered, or I should say Cali T2 and the PRP has considered, is having a rack of the FIONets available that could be scheduled as a resource for remote participation. But I like the idea of considering having a workshop that allows for remote workshop participants. That's great. Thank you.
Yeah, hi. So I was at the Copenhagen workshop,
yes,
which was very nice. And I think when you talk about removing all the bugs and stuff, I think you should keep those in because that was actually one of the things that you learned the most about seeing how the system reacts when it's badly configured. And it naturally gave this rise that you want to the Jupyter notebooks that you stop and pause and actually go back and reflect about what you just did when you see something that spits out an error. So as long as you know, as the teacher, how to fix it, then it's okay that they're in there actually.
Yeah. But that was feedback that we got. Yeah, that was a good. That is a good point. I mean, so that just as you were describing, I wasn't going to do a Jupyter Notebook demo, but I should ask, how familiar are people with Jupyter Notebooks, Jupyter Lab? So so a couple new things. So these, so the Jupyter Notebooks, maybe we can talk more about that at the reception, but it's the Jupyter Notebooks grew out of a project called IPython. And so it's a Python backend. And so it's a very powerful language that allows, in the case of the notebooks, it's quite literally where you can record what you're doing and run commands on remote resources and have the output captured in the notebook. And it allows you to replicate very easily those commands. And for teaching, it's wonderful because the instructor can see what the student's out is, just as we were discussing. If the output is other than expected, that the output is captured right there in the notebook. Kevin.
One more question.
John, so the students, have they been leaving with these configured FIONets for all 4 workshops, or is that something you just started this weekend?
I believe in all 4.
Okay.
All 4 workshops, they've been able to leave with a FIONet.
Do you have any? Have you heard about any impact? How those FIONets have been maybe put into use by previous participants?
So that's a good question. We've heard about what their plans were, right? So before they left, they would say, well, that was one of the questions, is like, what would you like to do at your home institution? So in one case, we had the FIONets were going to be kind of like the Kickstarter for that institution to set up a 1 gigabit connected DTN. So but I have to admit that we haven't gone back and actually understood from those participants what success they may have had since the workshop, or what further help we could offer.
If you have their email addresses, that might not be a bad idea to maybe reach out with an email sometime. And
that would be a nice thing. It's a great idea, Kevin. Thank you.
Also, while he's asking a question, one quick note is another participant was planning on sticking one of these FIONets next to a newsroom and collecting data that way, and then pushing it to their data stores. So, a couple of use cases you know of. You have one more question. Here, let me get this so that people can hear it on the broadcast.
So I know one of them is on its way to Iceland about now because they have a specific problem with one of our connections from Iceland to Denmark. So it's going to be used for that. And we have one of them installed at a university at Denmark where, well, it's where my office is, but still it's an institution that's outside our main offices. And then we have one that's not used as a FIONA really. It's being used as a running our Nagios screen. But yeah.
Cool. I think we've hit the end of our time, right? We had a half an hour scheduled for this.
So we have Bill saying we have 3 more minutes.
3 more minutes? Okay. Any final questions from anybody? More over here. Excellent.
So I'm curious, what's the best place for someone who wanted to get started with their own work? Well, I guess you put up some URLs, but get started with both PerfSonar toolkit and just like a self-revision FIONA appliance outside of coming to a future workshop. Do-it-yourself style, where's the best place to get started?
So there's the PerfSonar development team there's a lot of documentation on the PerfSonar website. I always also shout out to ESNet, their faster data page has an excellent set of resources there, including, and between them, they also have collections for low-cost hardware for PerfSonar nodes that cover some of the similar attributes to the FIONets that we used in our workshop.
And I would say we're available. So if you want my card or anything like that, we can help. Yeah, sounds perfect. I think we are right at the end of this session. So any final questions, or I think we're done? John?
I think we're done.
All right. So we're available during the reception.
Thank you.
Thank you.